Okay, just reviewing quickly what we did last lesson. In exercise 6.8, we did velocity in terms of x. That's what we did last lesson. Now, the main thing with this is normally in 2-unit, velocity is dx dt, right? And it always is dx dt anyway. So if you're given velocity now in terms of x as opposed to in terms of t, what did we do? Do you remember what we did?
Is it in terms of t or x?
Sorry. Through question 12 of exercise 6.8. Just for those that weren't here last lesson. So a particle has velocity, remember x dot is velocity, 1 over e to the power of 3x meters per second. Now that means that dx dt is 1 over e to the 3x. Normally, if we want to find the displacement, we've got x, v, a. You differentiate going down and you integrate going up. If we've got velocity and we want to find x, we have to integrate it. But the problem is, velocity we know is dx dt, but my velocity here is in terms of x, not in terms of t, which means that I can't integrate it the way it is. So what we need to do is take the reciprocal of the velocity. So instead of doing dx dt, I'm going to write dt dx, which is the reciprocal of 1 over e to the 3x, which is just e to the 3x over 1. Okay, so now I can integrate, because dt dx means that I need t in terms of x, and this now is in terms of x. So I can say t is the integral of e to the 3x dx. So now I can integrate, and I get t is integrating e to the 3x, don't I get 1 over 3 e to the 3x plus c. So basically last lesson you were given velocity in terms of x. Because you were given velocity in terms of x, you can't integrate. So you take the reciprocal, dt dx is the reciprocal of this, which is e to the 3x over 1, which is e to the 3x. So t is the integral of that. Now I can integrate with respect to x. Now I substitute. It says particle's got this velocity, 1 over e to the 3x, and the particle is at the origin when t is 3. T is a third, sorry. So when t is a third, its position is 0. So when t is a third, x is 0. We substitute that in. And what do I get? 1/3 is a third plus c. What's c? Therefore, c is 0. Now, in these cases where c is 0, if you don't integrate and put the plus c and show me that c is 0, you're still going to lose them up. Okay? And then it just says find the displacement when t is 7. So now that we know c is 0, we get t is 1/3 e to the 3x. Now we're just going to substitute what? T equals 7 to find x. So this is what we did last lesson. You will get harder ones of these once we've done acceleration, okay? So we get 7 is 1/3 e to the 3x. What do we do now? Times 3, so we get 21 is e to the 3x, and now we t logs, take logs of both sides. ln 21 is 3x, therefore x is ln 21 on 3, which is whatever. Exact. ln 21 is just ln 7 times ln 7 times 3. You can't simplify the ln 21. See, that is ln 7 times 3, which is ln 7 plus ln 3, but that's not simpler than that. Only if I could, which is ln 7 plus ln 3 on 3, but that's no simpler than that. So this is okay as an answer. So if you try and simplify that, look, it'd be different if it was ln 16 or something. Let's say it's ln 16, for example. That's ln 4 squared, or 2, sorry, no, that's not even simple enough. ln 2 to the 4, do you know what I mean, which is 4 ln 2. Now that is simpler than that. So that's not the simplified version this is. Whereas with the 21, you can't, that's more complex than that. So that's your answer there. You would only
So you can't
go further if you know that you're going to get some powers here, or like for example, girls, ln20 you'd have to do something with it, because what's ln20?
5 times
4 times 5, which is ln4 plus ln5. ln4 is ln2 squared, which is 2 ln2 plus ln5. I think that might be simpler. Yeah, that is. So, point 9 is acceleration in terms of x. So normally in 2 unit we've had velocity in terms of t, acceleration in terms of t. In the extension 1 part of the course we have velocity in terms of x. We know what to do with that now. Take the reciprocal, integrate. But we also have acceleration in terms of x. Now this one's a little bit more complicated than the other one. The rule is the following. You need to learn this. That acceleration, we know from 2 unit that acceleration is the second derivative of x. So it's d squared x by dt squared. That's what acceleration is. And we know that, now this is the new rule that we've got to learn, that it's d by dx of a half v squared, and we're going to prove it. So what you'll do in this type of question is that you're going to write d squared x by dt squared is d by dx of a half v squared, but we're going to have to prove that result, which we will. You'll notice that on your formula sheet you do have this. So d squared x by dt squared is d by dx of a half v squared. So it is there, so you don't have to remember it, okay? Now we're going to prove it. We know that acceleration, all right, we know that v is dx dt from 2 unit. We know that acceleration is d squared x by dt squared. Now girls, if you look at that, that's d by dt of dx dt. You know how v is dx dt. Isn't it d by dt of v? Yes? No? Do you get this? See how that's got the d squared x over dt squared? You're differentiating dx dt. And that gives you acceleration. Okay, so d squared x, look at it, d squared x dt squared, that is dt all squared, but that's how we write it. Okay, now we know that this is v, so that's d by dt of v, or dv dt, which is dv dx, because remember you'll have velocity in terms of x, times dx dt. We've got the proof there. Remember the dx's cancel. Now, that is dv by dx of, dx dt we know is v. Now, the next bit. That's the same as dv dx times d by dv of a half v squared. What does that mean? It means that if you've got a half v squared, it doesn't matter what's equal to a half v squared, and you differentiate that with respect to v. So d by dv of a half v squared, the instruction is to differentiate this with respect to v. How do you differentiate that with respect to v? What do you get? A half times 2v, which is v. So that's why they're saying that v is the same as differentiating a half v squared. So from there, they're saying that v is equivalent to differentiating a half v squared, which is d by dx So now the dv cancels, so that's d by dx of a half v squared. Okay, so you're given the result. Okay, given a question where the acceleration is in terms of x. Got it? That won't be the case in 2 unit. So acceleration is in terms of x. So you replace that d squared x by dt squared with d by dx of a half v squared from that formula sheet. So d by, in other words, if you differentiate a half v squared, that's what it's telling you, you get that 6x squared minus 4x minus 3. So if you differentiate this, you get that. Therefore, isn't it if you integrate this, you will get the half v squared? If you differentiate half v squared, you get that. Remember, integration's a reverse. So if you integrate this, you get half v squared. So that's what they're doing. The integral of the right-hand side equals half v squared. All right, that's the main thing. If you can't get that first line, you can't do the questions. So if you differentiate a half v squared, you get that. So therefore, if you integrate that, you get half v squared. Now, if you can't get that step, you won't be able to do it. So that's the important bit, all right? So therefore, half v squared is the integral of that. You get that plus c. You substitute your x and v because they tell you initially you're at the origin with a velocity of 3. You work out your c, you put it back in, and then you start answering the next part of it. Then you put it back in, but then you're going to have a problem here where you've got, so you've put it back in, then you multiply everything by 2 to get rid of the half, but then you've got v is plus or minus the square root. So what you've got to do then is go back to one of the conditions. It says when v is 3, x is 0, and you have to see, is it the positive version of the velocity formula or the negative version of the velocity formula? This is a really important step here. So it says v equals 3 when x is 0 is satisfied by the positive version, not the negative. So the negative version would be if the velocity was negative initially, to the left of the origin or something. All right, so you've got to determine which of those two equations, is it the plus or the minus one? And that's done by substituting one of the conditions that they'll give you, because you have to get a positive velocity. All right, always underneath the square root is going to be positive. So is there a positive out the front of the square root sign or not, or is there a negative? Once you've determined which one it is, then you just answer the question by a substitution. I think they'll do the same thing here again. Just looking, acceleration is 8x plus 1. They're replacing acceleration with d by dx of a half v squared. So therefore, if you differentiate this, you get that. So if you integrate the 8x plus 1, you get a half v squared. So you integrate with respect to x, you get a half v squared is that. Then you multiply by 2. You're supposed to multiply by, well, oh no, you don't yet. You work out your c first. Then you put the c in, multiply by 2, work out whether it's the positive or negative one.
Is c always 0?
Okay, it says since the particle moves to the left. Where does it say that? It says when the particle is 5 meters to the left of the origin. What's the initial? It starts at rest, but the particle is therefore moving to the left. After that, you'll need the negative velocity one down here. So with this one, you have to decide, is it the positive or the negative one? They're saying the particle's going to be moving to the left, it's the negative one. Velocity's got to be negative. All right, so let's do some questions. All right, I'll just put it on the side and we'll do a couple. Exercise 6.9, question 4. It says the acceleration of a particle is given by 3 cos pi x on 2 meters per second. And then it also tells us that initially means when t is 0, v is 2. Okay. And the question is to find v initially at the origin, yes, and x is 0. So when t is 0, v is 2 and x is 0. And part A wants us to find the velocity. So part A is to find v when x equals 1, positive 1. And then part B, show that the particle's never at rest. So part B is to show that v, it can never equal 0. All right, we replace the acceleration with d by dx of a half v squared. So we go d by dx of a half v squared equals 3 cos pi x on 2. Meaning, if you differentiate a half v squared, you get 3 cos pi x on 2. Therefore, a half v squared will be the, what do we do? Integral of 3 cos pi x on 2 with respect to x. Okay, now integrate 3 cos pi x on 2, and up here, there you go. Integrate cos, there it is. What do you get? Yeah, the 3 is just a constant. So yes, it's 3 times the integral of that, which will be 3 times cos pi x. What's the a in this case, please? What does a equal? Pi on 2, good. So it's 1 on a, so it's 1 divided by pi on 2, which is 2 on pi. Integrate cos, you get positive sign, and you just write what you've got. Pi x on 2 plus c will be there. Okay. Okay, good. Yeah, that's what a half v squared is. Yeah, don't multiply by 2 yet. I mean, you can, but just I would, yeah, we need a substitution for x and v, don't we? X and v. So substitute v is 2, x is 0. So just be careful here. That's the worst bit about that, that the a is the pi on 2. And we get a half times 2 squared is 3, which is 6. 6 on pi.
Miss, how do you know how to sub that in?
Because it's given in the question when t is 0, v is 2, and x is 0. So you're doing the substitution for v and x at the moment. You get sine of, well, that'll be sine 0, won't it? Plus c. What's sine 0? 0. Good. Half of 4 is 2. C is 2. Therefore, did you get this stuff up the top? Can I move? Therefore, a half v squared is 6 over pi sine pi x on 2 plus 2. Next step. Remember, we're trying to come up with the equation for v. What do we do now? Multiply by 2. V squared is, what do you get? Times this by 2. Just the 6 gets times by the 2 because it's 6 times that. 12 on pi sine pi x on 2 plus what? Good. Don't forget the 4. Now that's our formula. Now therefore v is plus or minus the square root of all that. Do not square root the 4, please, because it's not on its own. And we've got to decide.
Wait, Miss, no, we still have x for 1.
Wait a sec. We know initially the particle is at the origin with velocity 2. So we know that when x is positive 2, when v is positive 2, x is 0. So when x is 0, v equals positive 2. Therefore, you have to have the positive version of this because the square root of 4, when x is 0, you get 0, sine 0. Sine 0, 0. 0 plus 4 is 4. So therefore 2, why have I got plus or minus? When x is 0, v is positive 2. So therefore 2 has to be the positive square root of sine 0 plus 4. Does that make sense? 2 is, don't worry about the 12 on pi. You can. 2 is the positive square root of 4, isn't it? So it's the positive version. Do you see why? Because you're told initially when x is 0, v is 2 meters to the right. So if you substitute x is 0, you've got to get v is positive 2. It's not just where the particle's going afterwards. You don't look at that. You need to look at a set of conditions that you've got. Now, in the second example, it said when v is 0, x is 0. We couldn't tell whether the v was the positive one or the negative one. But with this one, we can. They've told us when x is 0, v is positive 2. In the second example that we looked at before, we had to see where the particle was going to know if v was the positive or the negative version. So therefore, v is the positive version. of this formula. And now you can we can start to answer the question. Now the question is, find the velocity when x is 1. So sub x is 1. And you get velocity is the square root of 12 over pi sine pi on 2. Sorry, this is like that. That's not like that. Fix that. Sine pi on 2 plus 4. What's sine pi on 2? Because when sine 90 is 1, good. So it's the square root of 12 on pi times 1 plus 4. How are you going to do that, girls? Pi's, can you make pi? So it's 12 on pi plus 4. Do you want to make a common denominator? That would be 12 plus 4 pi on pi. Square root of 12 plus 4 pi on pi. You know you can actually simplify that. Oh yeah, they want 1 decimal place. Off you go. But how would you simplify it? Wait. What can you take out as a factor on the numerator? I just want you to see something. Can we do that? 4, 3 plus pi on pi. I want you watching this. I'm not saying you've got to do it with this question, but what could you take out now? That's the square root of 4 times the square root of all that. So it becomes 2 square root of 3 plus pi on pi. That's the most simplified version of that. See, 4 is a common factor on the numerator. That is really the square root of 4 times the square root of the rest of it. So that is the same as 2, and make sure it's a big 2 and it doesn't look like the second root of. And then you can do exact. Sorry, you can do your 1 decimal place. But if they wanted the exact, they would be expecting this simplification. If you can't simplify it properly, don't simplify. You're better off not making the mistake. A few ways we can do this. This might be the easiest way for you to sub v is 0 and show that you'll never get a solution for x. Okay? Sub v is 0, you get 0 equals that square root. We can square both sides. Remember, the square just gets rid of the square root sign, and you get 0 is 12 on pi sine pi x on 2 plus 4. Now, what could you do next? Take the 4 to the other side. So you get negative 4 equals 12 on pi sine pi x on 2. Now, I would sketch that curve and show, tell me what the amplitude of that curve is. What does 12 on pi equal? I need an approximation.
12 on pi.
Yep. 3.819, that's approximately 3.819 sine pi x on 2. So if you actually sketch that, if you sketch it, tell me what the amplitude of that is. 3.8. So here's 4, and there's negative 4, and guess what? Your curve never touches it, never reaches there. 3.8 ... Do you get it? Yeah. So you will never ever be able to reach negative 4. Negative 4 is down here, and your curve never touches it. Your curve has an amplitude of 3.8. I mean, if you want, you can work out the period, but you don't need to. But what is the period? So the amplitude is approximately 3.8. Does that make sense? I'm sketching that curve. When you try and solve that with that, you're supposed to be able to draw this and show that it can equal negative 4 at some stage. If I put negative 2 here, yes, I know that this curve cuts through negative 2. But this curve never will have a value of negative 4. It'll only have a value of negative 3.8. That's the biggest value, negative value that I can get. So amplitude's approximately 3.8. I mean, if you want, you can do the period, but it's not necessary. What is the period? Isn't it 2 pi divided by what? Divided by the coefficient of the x, which is what? Pi on 2. What's 2 pi divided by pi on 2? It's 2 pi times 2 on pi, which is 4. So guess what, girls? Your periods don't always have to have pi's in them, and you're going to see this a lot when we do simple harmonic motion. You won't be uncomfortable with this happening. but the period is actually 4 here. If you look at the question, which axis is this? That's the x-axis. That's the position. And that's the velocity, because I'm sketching that curve. All right? So, can you see, therefore, velocity will never be, that can never equal -4. So, therefore, remember, the -4 happened because we took that +4 over. So, this has no solution. This equation has no solution. Does that make sense? So period is 4, amplitude is 3.8, therefore 12 over pi sine pi x on 2 can never equal -4, therefore v can never equal 0. Because why did you get the -4? Because you took, originally v was 0, but we took this 4 over to the other side. That's one way of doing it. I don't know if this way is getting many fans. But it's important that we know this way, because I'll show you something else. I want to show you something else. You know how sine x equals a half? Give me a solution between 0 and 360. What does x equal? Sine what's a half? Quadrants? Sine what? 30 is a half, and sine? Good. That means the way you can solve this is like this. There's the sine curve. That's 360. That's 180, 90, 270. So that's sine x drawn. The other thing you can draw is y equals a half. What's the amplitude of the sine x curve? So if you want to solve this, this is what you do. You sketch y equals sine x. You sketch y equals a half. Just watch what I'm doing, because I know there are some people that were still blank. You sketch y equals sine x, you sketch y equals half, and to solve simultaneously, you end up with sine x equals a half. So I've sketched y equals sine x, amplitude of 1 and -1. I sketch y equals a half, which is there. Can you see your solution would be 30 and 150? So if I said to you solve sine x is 1.5, what are you going to tell me? Is there a solution or not? 1.5 is up here. Sine x is 1.5, has no solution, because the sine x curve goes between 1 and -1. Now, that's the other way of approaching it. So we're going to go back to that problem now, and we're going to approach it that way. But this is what... So if you've got y equals sine x and y equals a half and you solve simultaneously, you're really solving sine x equals a half. To solve simultaneously, you can do graphing. You graph the first function and you graph the second and look for points of intersection. Now that's what we're doing here. We're graphing that 12 on pi sine pi x on 2, and we're graphing y is -4, or in this case v is -4. We're showing that they never overlap, so therefore there's no solution. There's no point of intersection. But if I had -3 here, yes, I'd have 2 solutions there and there. Now, there is another way to do this question to show that v is never 0. There's another way. So I'm just going to write the formula out. V equals the square root of 12 on pi sine pi x on 2 plus 4. The other thing we're going to do is we're going to say the amplitude, or no, why don't we say the values. Now what you've got to do is draw it again. So I'll draw it. I'm drawing this. So I'm drawing 12 on pi sine pi x on 2 plus 4. I'm drawing it. No, I'm not drawing the plus. I can draw the plus 4. Actually, that's that. That's that. If I do the plus 4 version, where does it go? Good. And it goes up here somewhere and like this. That's your other option, is to draw this, but be careful. That's 4. This doesn't hit 0, because remember this amplitude is 3.8. So that's above 0.
That's like 0.7.
Right? And you say that this is the v-axis and that's the x-axis. So therefore, v can never be 0 because the graph does not cut. You never have v is 0. The graph does not cut the x-axis. V cannot equal 0 as the graph does not cut the x-axis. Now for this version of the question, of course, again you say amplitude is pi on 12, which is approximately 3.8. And you can do the period if you want, but there's no need. It's not necessary. But if you have to, you can do the period. Main thing's the amplitude, and you can show that that curve never touches the x-axis. That's your other way of doing it. It's okay. Question 12. The rocket's acceleration is given by acceleration is negative k over x squared, where x is the distance from the centre of the Earth. And if the rocket, so what else do we know? That when t is 0, it starts. That's the time. And if the rocket starts from rest at the surface of the Earth. Now, x is the distance from the centre. The radius.
V0 as well?
Yeah. It's, yes, from rest. V is 0, but x is 6,400 kilometres. Because x is the distance from the centre of the Earth, and the rocket starts at rest from the centre of the Earth and off it goes. Okay. So we have to find an equation for the velocity of the rocket in terms of x. So let's start. Acceleration is d squared x by dt squared, which happens to be d by dx of a half v squared, which is negative k on x squared. So you don't need all that. So we just write d by dx of a half v squared is that. So if you differentiate that, you get this. Therefore, if you integrate the right-hand side, you get that. So a half v squared is the integral of negative k on x squared dx. How do you integrate that?
Are we trying to make it like times by 2, bring the k out?
Bring it up. X to the negative 2. That's how we integrate it. So a half v squared is the integral of negative k x to the negative 2. Please physically raise the power by 1 and say to yourself negative 2 plus 1. Don't put negative 3. That's what I'm trying to say. Don't put negative 3. You have to say negative 2 plus 1 to yourself. You know how many people will put negative 3? A lot. A lot. So that's why you make it, you go negative 2 plus 1, you say it to yourself under your breath. And you get negative 1. I don't care if you sit on a number line and jump up. Just don't make the mistake. Okay, plus c. So that's what a half v squared is. So what do you get? Get rid of that negative. K. K on x. That's right. The negatives go. K on x plus c is a half v squared. Not too bad. What do we sub? When v is 0, we can only do a vx substitution. X is? Yeah, these aren't too bad, girls. So a half times 0 squared is k over 6,400 plus c. What do you get?
C equals negative.
What's k? Oh, yes, it is. We've got a k in it. Oh, maybe we have to work it out. So therefore, c is negative k over 6,400. So therefore, a half v squared is k on, no, yes, it is, minus k on 6,400. Yep. Times everything by 2. You get 2k on x. All right, so I got c is that, so therefore I substituted the c into that. And now we get v squared is multiplying both by 2. What's 2 on, well, 3,200. No, because you integrated the x squared and you got on x. You look, a half v squared is k on x plus c. So now we get 2k on x minus k on 3,200 is v squared.
Can you not sub in what x and v is again to get k? Because the answer has k's in it.
Yeah, because it doesn't have enough. You'd need some other information, because when v is 0, the only way we're going to get this is if k is 0, because you can't have x is 0 because it's on the denominator. So if you're given the velocity at some other time apart from v is, sorry, if you're given a velocity other than v is 0, then we'll be able to work out what k is, but we haven't been given a velocity other than 0. Okay? But if you are, you could. So if you're given a v and an x where they're both not 0, then you can work out k. But we haven't been given it. So it's plus or minus. Now what's going to happen? Now we've got to work out if it's the positive or the negative. X is already at 6,400. Rocket goes up. That's away from 0. That looks up is positive. When the rocket comes back down, but it's going to reach, yeah, then velocity would be negative. So it's the positive version. I'd put as V, rocket's going up. As rocket goes up, V is greater than 0. That's a bit messy. No, but the velocity is, yeah, but no, if the rocket's coming down, see, if this is 0 on my scale and this is already, I'm sitting at 6,400, and the rocket's going up as well, away from the centre of the Earth. Do you know what I mean? The rocket's also going away. If the rocket's coming back towards 0, back towards the centre of the Earth, you know, like on a number line, if that's the origin, velocity like that's positive, coming back towards the origin, or that way is negative. So it's the same sort of thing. You're moving away, but up is positive, down's negative, to the right is positive, to the left is negative. So homework will be to do greatest velocity. You need to draw the curve or whatever and see where the velocities are maximum. 9, so we've got 9, 10, 11. You may as well do 8. Why don't we start from 6? 6 to 11. I don't think you need the others. And look, do we need 6? I want you to do 6 because it's got the ln. 6 through to 6, 7, 8, 9, 10, 11. That's 6 questions.
I just texted you.
6 to 11.
6 to 11?
Exercise 6.9. Questions 6 to 11.